In the deep darkness of the ocean, where sunlight barely reaches, ancient hunters still patrol the seas. Long before dinosaurs walked the earth, they were already here, hunting, evolving, surviving. Creatures with extraordinary senses, teeth that never stop growing, and a silent power hidden beneath the waves. Sharks. For many people, they are symbols of fear. But in truth, they are among the most important guardians of the oceans. Ancient survivors that have carried the secrets of life through the darkest waters of our planet. This is the story of sharks, predators that have ruled the oceans for hundreds of millions of years. Sharks are cartilaginous fish recognized by their flexible skeletons, multiple gill slits, and skin covered with tiny tooth-like scales. Modern sharks belong to the group Selachii, and their closest relatives are the rays and skates. Some species stand at the very top of the ocean's food chain. Apex predators, such as the great white shark, the tiger shark, the bull shark, and the hammerheads. But the story of sharks is far older than today's oceans. Their ancestors appeared more than 400 million years ago. Modern sharks emerged around 200 million years ago during the Jurassic period. Shark sizes vary dramatically, from the tiny dwarf lantern shark, just 17 centimeters long, to the whale shark, the largest fish on Earth, reaching nearly 18 meters. Sharks inhabit every ocean on the planet, often diving as deep as 2,000 meters. Most live in salt water, but a few species, like the bull shark, can survive in both salt and fresh water. Ancient predators that have ruled the oceans for hundreds of millions of years. For many years, sharks were seen as solitary hunters, predators silently roaming the oceans in search of food. But that image applies to only a few species. Most sharks live far more social lives. Some gather in large groups and even show signs of social behavior and individual personalities. Even solitary sharks meet one another for breeding or in areas rich with prey. During these journeys, they may travel thousands of kilometers across the oceans. Migrations that can be even more complex than those of birds. Some species cross entire ocean basins. In certain places, sharks gather in remarkable numbers. More than 100 scalloped hammerhead sharks have been observed around seamounts and islands, such as those in the Gulf of California. Among them, a form of social hierarchy also exists. For example, oceanic white-tip sharks often dominate silky sharks of similar size when feeding. And when threatened, some sharks perform a warning display. Exaggerated swimming movements that send a clear message. Do not come any closer. Like other fish, sharks extract oxygen from seawater. As water flows across their gills, oxygen is absorbed into the bloodstream. But unlike many fish, a shark's gills are not covered. Instead, their gill slits appear as a row along the sides behind the head, just behind the eye. Of many sharks is a small opening called a spiracle. This structure allows water to enter the body during breathing. It is especially important for sharks that live close to the ocean floor. But in fast-swimming open ocean sharks, the spiracle is greatly reduced or even absent. When a shark swims, water enters the mouth and flows over the gills, a process known as ram ventilation. When resting, most species actively pump water across their gills to maintain a steady supply of oxygen. Yet a few sharks have lost this ability. They must keep swimming in order to breathe. These species are known as obligate ram ventilators. And if they stop moving, they may suffocate. A shark's teeth are not anchored directly to the jawbone. Instead, they are embedded in the gums. And throughout life, they are constantly replaced. Behind the active teeth, several rows of replacement teeth are already forming. Gradually, they move forward toward the front of the jaw, a system often compared to a conveyor belt. Over a lifetime, some sharks lose more than 30,000 teeth. The replacement rate varies by species. In some sharks, a new tooth appears every 8 to 10 days. In others, the process may take several months. In most species, teeth are replaced one by one. But in a remarkable exception, known as the cookie-cutter shark, an entire row of teeth is replaced all at once. A relentless system ensuring that a shark is always armed with sharp, fresh teeth. One of a shark's most powerful senses is its sense of smell. Short olfactory canals, located between the nostrils, detect chemical traces in the water. An astonishing ability. Some sharks can detect a single drop of blood among 1 million drops of seawater. The size of the shark's olfactory bulb varies between species. Sharks that live in dark or murky waters often possess larger olfactory centers. But in clearer environments, such as coral reefs, sharks rely more on vision, and their olfactory bulbs are smaller. Sharks can even determine the direction of a scent. They compare the time it takes for the odor to reach each nostril, a method remarkably similar to how mammals locate the direction of a sound. These predators are particularly sensitive to chemicals released from the bodies of other animals, which is why they are sometimes found near sewage outflows. In some species, such as the nurse shark, whisker-like sensory organs called barbels help them detect prey along the ocean floor. A shark's eyes are remarkably similar to those of other vertebrates. They possess a lens, a cornea, and a retina. But shark vision is specially adapted for life in the ocean. One of the most important adaptations is a structure known as the tapetum lucidum, a reflective layer behind the retina that sends light back through the eye. This reflection greatly enhances vision in dark waters and at night. In some species, this adaptation is especially powerful. Many sharks can also contract and expand their pupils, an ability that most bony fishes do not possess. Sharks have eyelids, but they do not blink. The surrounding water naturally cleans their eyes. For protection, some species have a special covering called a nictitating membrane. This protective layer slides over the eye during a hunt or when threatened. But not all sharks have this shield. The great white shark, for example, lacks this membrane. Instead, when it attacks, it rolls its eyes back into the sockets to protect them. A swift reflex from one of the ocean's most formidable predators. The hearing of sharks is difficult to study in detail, but evidence suggests they possess highly sensitive hearing. Sharks may be able to detect the sounds of prey from great distances, even several miles away. Most species are sensitive to sounds within a range of 20 to 1,000 hertz. On each side of the shark's head, there is a small opening connected by a narrow canal directly to the inner ear. But sharks possess another remarkable system, a delicate sensory structure running along both sides of the body, known as the lateral line. a series of tiny pores capable of detecting the faintest vibrations in the water. The inner ear and the lateral line are part of a single sensory network, an evolutionary system designed to detect sound and movement. Scientists call it the acoustico-lateralis system, a system that allows sharks to sense hidden motion in the dark depths of the ocean. Sharks possess extraordinary sensory organs known as the ampullae of Lorenzini, specialized receptors capable of detecting electrical fields. A single shark may have hundreds or even thousands of these organs. All living creatures generate faint electrical signals, and sharks can sense them, even when a prey animal is hidden beneath the sand on the ocean floor. This ability is particularly refined in species such as the hammerhead sharks. In fact, sharks possess one of the most sensitive electrical detection systems in the entire animal kingdom. But this sense is not used only for hunting. Ocean currents moving through Earth's magnetic field generate weak electrical signals, signals that sharks may use for orientation and navigation across the vast oceans. An invisible sense that allows these predators to read the hidden signals of the sea. Sharks are among the ocean's top predators, but they do not all hunt in the same way. Each species uses its own strategy. Some sharks are hunters of speed. They launch sudden attacks toward their prey. A famous example is the great white shark, a predator that strikes from below, rising from the depths in a powerful upward attack. A sudden impact that catches prey completely off guard. Other sharks are masters of ambush. They lie motionless on the seafloor, waiting. When prey comes close, the attack is swift and deadly. Species such as angel sharks use this method. Some sharks do not always hunt alone. At times, they hunt in groups. Several sharks surround a large prey animal, attacking again and again until the victim weakens. In other cases, sharks rely on exhaustion hunting. They pursue their prey repeatedly until it tires. Then the final strike is delivered. Whatever the method, speed, razor-sharp teeth, and extraordinary senses make sharks among the most efficient predators in the history of the oceans. For most of their lives, sharks swim at a steady pace through the oceans, cruising at an average speed of about 8 kilometers per hour. But this calm motion can change in an instant. When the hunt begins, their speed can surge beyond 19 kilometers per hour. Among all sharks, one species stands out for its remarkable speed. The short fin mako shark, one of the fastest fish in the entire ocean. In short bursts, this predator can reach nearly 50 kilometers per hour. Even the great white shark is capable of sudden acceleration. This impressive speed may be linked to their unique physiology and a form of regional warm-bloodedness. In search of prey, sharks can travel as much as 70 to 80 kilometers in a single day, silent hunters moving through the ocean with astonishing speed. The lifespan of sharks varies widely between species. Most sharks typically live between 20 and 30 years, but some species live far longer. The spiny dogfish, for example, can survive for more than 100 years. The gentle giant of the oceans, the whale shark, is also believed to live for more than a century. But one species stands apart. The Greenland shark, a mysterious predator of the cold Arctic seas. For many years, scientists believed it lived around 200 years. But recent research revealed something extraordinary. A specimen more than 5 meters long was estimated to be nearly 400 years old, making the Greenland shark the longest living vertebrate ever recorded, a creature that may drift through the dark Arctic waters for centuries. Unlike most bony fish, sharks follow a very different reproductive strategy. They are considered K-selected animals, meaning they produce fewer offspring, but those young are far more fully developed. Instead of releasing thousands of tiny larvae, sharks invest in a smaller number of well-developed young. The number of pups varies greatly between species. In a single reproductive cycle, a female shark may give birth to as few as 2 pups, or in some cases, more than 100. Sharks also reach sexual maturity much later than many other fishes. For example, the lemon shark typically matures at around 13 to 15 years of age. Sharks use 3 different methods to produce their young. Some species lay eggs, others give birth to live young. And in certain species, eggs develop inside the mother's body before the pups are born. 3 different strategies for continuing the lineage of one of the ocean's oldest predators. Sharks are more than powerful predators. They are guardians of balance in the oceans. Many shark species occupy the very top of the marine food web. As apex predators, they regulate the populations of other species. Sharks often target the weak, the sick, or the slow. In doing so, they help maintain healthy marine populations. When sharks disappear from an ecosystem, the natural balance can quickly collapse. Certain species may suddenly increase in number, and this surge can trigger a chain reaction throughout the ecosystem, a phenomenon scientists call a trophic cascade. In extreme cases, even coral reefs and marine habitats can suffer severe damage. This is why sharks are essential to the health of the oceans. They are not only predators, but invisible regulators of life beneath the sea. Despite their power and ancient lineage, sharks today face serious threats. The greatest danger comes from humans. In many parts of the world, sharks are hunted for their fins. In a practice known as shark finning, the fins are removed and the body is often discarded back into the ocean, a practice that almost always leads to death. Industrial fishing and the destruction of marine habitats have also caused sharp declines in shark populations. The problem is made worse by the shark's own biology. They grow slowly and reach maturity late in life, which means their populations recover very slowly. Today, many shark species are listed as threatened or endangered, and as their numbers fall, the balance of the oceans is placed at risk. For hundreds of millions of years, sharks have survived mass extinctions and dramatic changes in Earth's history. Yet today, their greatest challenge is not nature, but us. Protecting sharks means protecting the health of the oceans, and the fate of the oceans is ultimately linked to our own. Because on a planet covered mostly by water, the health of the seas is the health of the Earth itself.